Be graphing quadratic functions now. All right, so a quadratic function is going to be a function with an input and an output, right? Typically an x and a y, and this is one in standard form, where you have the output right here, which you can write as y, or you could say f of x or something like that in function notation. And notice this thing is quadratic. It has an x squared term, it has an x term, and then it has a constant where a, b, and c can be any real number, right? And of course a can't be 0 because then it would be linear, there'd be no x squared term. Right, so this is a quadratic function. So what does a quadratic function look like? All right, so a quadratic function is going to be, when you graph it, it's going to be like a parabola. So we're going to start with the most basic quadratic function, which is going to be y is equal to x squared. All right, and so what I'm going to do over here, I'm just going to choose some x values and get some y values. So I'm just going to choose -2, -1, 0, 1, and 2. All right, so let's go ahead and plug them in. And like when we did absolute values, I'll show you how to find the middle value that you're going to plug in. So we're going to plug in -2. -2, when you square -2, when you square a negative number, it becomes positive. You're going to get 4. When you plug in -1, when you square a negative number, you get a positive number. -1 squared is going to be +1. Plug in 0. 0 squared is 0. Plug in 1. 1 squared is 1. Then plug in 2. 2 squared is going to be 4. And you're going to graph this now. You're going to have -2, 4, -1, 2. -1, 1 rather. 0, 0, 1, 1, and 2, 4. These are going to be curvy. They're going to increase faster and faster as you go further to the right. And they're going to look like that. They're going to be parabolic. So this right here is the vanilla function right here, the most basic one. That's going to be that. That's that graph right there. And this thing is going to have a vertex at 0, 0, that min or that max. The vertex is at 0, 0. And the axis of symmetry is going to be the vertical, I'll say dotted line. It's just going to be the vertical line which the function is symmetric with respect to. So the axis of symmetry over here is x equals 0. It's the vertical dotted line, all right, with which it's symmetric. And the axis of symmetry is always going to be x equals the x value in the vertex, okay, because the vertex is always on the axis of symmetry. Okay, so we graphed that right there. That's y equals x squared. Let's also say that for these two, the domain for any of these is going to be all reals. I'm just going to write x as an element of the real numbers. That means all. You can just write all reals, because the x value, you notice that there's going to be a dot for every x value, right? For over here, it'd be way up here, but you get the point. You can always get x values. All the points, this thing goes forever to the right and forever to the left. It works for every x value. And the range over here is going to be, you could say y is greater than or equal to 0, or you could say it goes from 0 to infinity, like that. Okay? So that's that most basic function y equals x squared. Okay? Now we're going to talk about y equals -x squared. All right, and so we'll graph the same points, -2, -1, 0, 1, and 2. All right, when you plug these in, negative 2 squared is 4, and then you take the negative in front, so it's going to be negative 4. Negative 1 squared, you plug that in, negative 1 squared becomes positive 1, then you do the negative in front. So you do the exponent before you do the negative in front. You do exponents before you multiply by the negative 1 in front. I'll just make this quick right here, because this is getting kind of long. So this is going to be negative 4, negative 1, 0, negative 1, negative 2, negative 4. Negative 4 for the last one. All right, and when we graph this is going to look like this. All right. When you have a negative in front of the lead coefficient right here, see it's negative 1, it's going to point down. This thing also has a vertex at 0, 0. This thing also has a axis of symmetry. You know, I'll just write them AOS now. At x equals 0. And the domain over here, for any of these functions, it's going to be x is greater than or equal to the real numbers. X is an element of the real numbers. You can just say all reals. Or you could put it, you know what, we could also put these in interval notation as well. I don't care which way you write it. It goes from negative infinity to infinity. You can say it that way. From negative infinity to infinity. And the range is going to be y is less than or equal to 0 for this one. Right? Which is the same as you saying it goes from negative infinity to 0. I'll stick with one method of writing the domain and range. You know what? I'm just going to stick with this way from now on. Okay? Because that's what Mrs. Barr was doing. All right? All right. So that's the first video.